So first off, so simplifying variable expressions. We need to have, we're going to be dealing with algebraic expressions. What does it mean to have an algebraic expression? We talked about these yesterday. What is an algebraic expression made up of?
So it's there's a letter that replaces the number,
which is called a
variable.
So an unknown number would be a variable, and then what does an algebraic expression also have to have?
It has to have coefficient.
Okay, it could.
No.
So algebraic expressions have to have variables and they have to have operations.
Oh yeah.
Okay, so if I gave you this algebraic expression, 2m plus 5m.
Oh.
Okay? Let's talk about the parts of an algebraic expression. Okay? What are my terms? And a lot of you have had this already. So what are terms? Terms are what, Mason?
Numbers like
What are terms separated by?
the plus, minus.
Okay, addition and subtraction. Okay? Terms are subtracted or separated by addition and subtraction. So, how many terms do I have here? How many terms do I have in this problem? Audrey?
2.
2. 1, 2. Okay? Now how many terms do I have?
3.
3. Does everybody understand what a term is? So this is one of the terms. This is another term. This is another term. Okay? Within this algebraic expression, I have variables. Can anybody tell me what my variables are? So terms equal, we have 3. What is my variable? Okay, so hold on. What variables do I have? Do I have multiple variables?
Yes. No.
Yes or no? What do you think?
M.
I have one variable. What's my variable?
M.
M, right? So my variable is M.
Oh.
Okay. What is my coefficients? How many coefficients do I have? Oh man, I'm gonna have to look up the spelling on that one. What is a coefficient, first of all? Get it?
A number before a variable.
Okay, good. So it's going to be the number that is partnered with the variable. So when you multiply with the variable, the coefficient would be right in front. So what are my 2 coefficients? I have 2 coefficients here. What are they? Which 2 numbers are paired with the variable?
2.
Come on, let's go. More participation. Maddie?
2 and 5.
2 and 5. Good. 2 and 5 are my coefficients. Okay, and then I have a constant. So we're just breaking down an algebraic expression. What is my constant? This value remains the same because there's nothing put with it. It is what it is. AC? The 6. Good. It's actually minus 6. So like a negative 6. Because when we deal with algebraic expressions and numeric expressions, we need to start thinking in terms of, okay, this is negative 6. All right? Yes, negative 6 and minus 6 are the same thing. So this 5m, is that positive or negative?
5 minus negative.
Right now, is this positive or negative? Positive, unless the m was negative, because positive times negative would be a negative. Is my 2m positive or negative?
Positive.
Positive. 2 is positive, right? Okay, but it would depend on what m is. Okay, so simplifying variable expressions. Basically, that means that we want to compact it. We want to make it easier. That's all it means. Okay, does it say to solve? No. We're not evaluating, we're not solving, we are simplifying. So, when we talk about simplifying, we want to combine our like terms. So what do we mean by like terms?
Combine the numbers that have like the same letter behind it.
Okay, so if they have the same variable,
It doesn't have to have a letter behind it.
we could combine those. Okay? So in this problem, do I have like terms?
Yes. Yeah.
What are they?
2m and 5m.
Okay, so I'm going to underline those. 2m and then plus 5m. Would negative 6 or minus 6 be a like term?
No.
Not with that, because what does it not have?
M.
It doesn't have m. So you're saying that you're taking 2 times m and 5 times m. I'm not taking 6 times m. So that is a separate term. So now we just combine. What is 2m plus 5m?
7m.
7m. And then I just bring down my minus 6. Does this look more compact than that?
No. It's easier.
It's easier. It's simplified. It's made easier. Okay, let's do another one. Let's go with 5x plus 8 minus 3x plus 3. All right, help me out. What are my like terms? What are my like terms? And actually, I'm just going to throw this out there. Sometimes, some people teach it that you would, so you see how this says minus 3x?
Yeah.
Some people would say, okay, let's put a plus a minus 3x. So you change everything to an addition problem.
Right.
Okay. So you could do that. I don't necessarily see a lot of value in that, but that's just my own opinion. So what are my like terms? Help me. So we're going to visually do it. Let's underline a like term. Maddie.
5x.
Okay, 5x. What else should I underline? Okay, and it's not necessarily 3x, but what is it? Negative 3x. So plus the minus 3x. So the way I like to look at it is, I just look at it as minus 3x. Okay? So what would I get when I have 5x minus 3x?
2x.
I would have 2x. Does that make sense?
Oh, I know that.
What if this was an addition sign? What would I have?
Plus.
What would this become? That'd be 8x. Do you see the difference? This is minus 3x. Okay, do I have any other like terms? I'm not done until I get all the way through it. Paige? Okay, 8 and 3. I'm going to put a box around those. 8 and 3. And those are like terms because they are both what? They're both constants, right? So what do I get when I have 8 plus 3? 8 plus 3.
11.
Okay. Plus 11 or minus 11?
Plus.
Plus 11. Does this look more simplified than that? Yeah, but it's the same exact problem. If you substitute x in, right here, let's say that x is 2. What's 2 times 2?
4.
Plus 11. 15. What's 5 times 2? What's 3 times 2? 6. So I have 18 minus 6 is 18. 10 plus 8 minus 6. 18 minus 6. 12 plus 3. 15. You get the same answer. This is just simplified. Alright, let's look at one more. Alright. 4 plus 3n minus 2x plus n minus plus n no, let's go plus 5x. Okay, help me with my like terms. How many terms do I have?
1, 2, 3, 4.
How many terms?
Oh.
1, 2, 3,
4, 5.
4, 5, right? Okay, which ones are like terms? Which ones can be combined? Gideon? The x's, the ones with x's on the end, okay? What if this said, oh, never mind, I'll show you that in a second. All right, so I'm going to underline those. Minus 2x plus 5x. Okay, what else are like terms? What else are my like terms? Aaron, what else? What other like terms do I have? Okay, the ends. So I'm going to put boxes around those. plus 3n plus n. What can I put in front of the n? A 1, right? Because wouldn't you agree there's 1 in there? And it just helps you to see it visually that you have a 1 there. There's 1 n. Does the 4 have a like term? No, so I'm going to circle that. I'm just going to do something different for all of them. So now let's just write down what we have. I have 4. Let's go to our n's. 3n plus 1n. What do you get? Plus 4n. All right, this is a trickier one. You have negative 2x. Or you could change this to what? Plus negative 2. And then you have a positive 5x. So what is 5x plus 2x?
7x.
But this says plus a negative 2x. So it would actually be 5x minus 2x.
3x.
Does that make sense?
Yeah.
So what do we get? We'd have 3x. Are they positive or negative?
Positive.
Positive, right? Because you have more positives. So plus 3x. That would be my simplified version of this algebraic expression. Okay, last thing. If I have these two terms, 4m and 4mx plus 4m plus 2x. Can I combine any of those terms?
Yeah. No.
Remember, they have to be exactly the same.
No.
What does this one have? This is saying 4 times m and times x. What's this only being multiplied by? Only by n, that's only being multiplied by. So that's my simplified version there. Okay, it has to be the same. Now what if I had this? Plus 2mx.
Then you can do
What could I simplify?
the 4 and then add the 4 now.
The 4mx and the becomes what? 6mx, because I have 6 of them now. And then I would just bring everything else down. Plus 4m plus 2x. All right. Thanks, Jenna.